additional topics number 2 is slope fields and differential equations. All right, this is one that is always on the AP test, especially free response problems. This is always one of the free response problems, so this is very, very important. All right, so a differential equation is an equation that contains an unknown function and one or more of its derivatives. So we've kind of talked about differential equations before. So number 1 says, show that y equals x minus x to the negative 1 is a solution to this differential equation. So I have y. I need y prime for my equation, so go ahead and find y prime. So y prime is 1 minus, the negative 1 goes to the front, so plus x to the negative 2. So all we're doing is we're just plugging into this equation to see if it's true. So I'm gonna plug in on the left side, and I'm gonna slowly simplify until I get just 2x. So hopefully I can get the left side equals the right side. So I have x times y prime is 1 plus x to the negative 2 plus y. So what was y? X minus x to the negative 1. So keep simplifying. So I usually write, this is left-hand side. This is how I usually do my little proofs. I say left-hand side is this, and then I keep simplifying until I get the right-hand side. All right, so multiply your x in, so I get x plus x times x to the negative 2. It's x to the negative 1, right? Plus x minus x to the negative 1. This one's pretty easy. Your x to the negative 1 minus x to the negative 1 goes away. So I get 2x. That's your right-hand side.
Wow, that is so beautiful.
Okay, so that shows. Yeah, you can do your little square. Yeah. All right. So next up, so show that every member of the family of functions, 1 plus c times e to the r over 1 minus c e to the r is the solution of the differential equation. This one's harder. All right, c is any number, so any constant. It's just the same on the top and the bottom. That's why it's called a family of functions. So c can be any number that you want. All right, so let's find y prime.
We already have y prime.
We have y. But we're showing that it's equal to this. So let's find y prime. So y prime is low. Is that an R or a T? I can't tell. Oh, it's a T. So low times derivative of high. So it's just c e to the t.
Do you need to have the first part in parentheses so that it doesn't look like you don't multiply?
Minus high. No. D low all over the square of what's below. Good. All right, try to combine as much as possible. So we're going to distribute. So I get c e to the t minus c squared e to the, you add your powers, so 2t. That's a 2 there. Doesn't really look like a 2, but. All right, minus. I distribute my negative in. I'm going to go ahead and put parentheses because this will be a little messy. So I have negative c e to the t minus c squared e to the 2t. Oh, I'm writing, I promise. It's just delayed. C squared e to the 2t. Okay, so now distribute your negative. So I get c e to the t minus c squared e to the 2t plus c e to the t plus c squared e to the 2t. Let's see how those cancel. Okay, so let's go ahead and start with this differential equation. So I want to show that y prime is equal to 1/2 y squared minus 1. So let's start with the right-hand side this time. So I have 1/2 y was 1 plus c e to the t over 1 minus c e to the t. So I'm going to square it and then subtract 1. It's going to be messy. I guess I didn't finish out the y prime, so you could just say it's 2c e to the t over 1 minus c e to the t squared. So I just combined my c e to t's. All right, so I need to square this or FOIL this in. It's going to be kind of messy. Can you guys see what it's going to be? So I'd have 1 minus 2c, or plus c e to the t, plus, I'm going to square this, so I get c squared e to the 2t. Do you guys need to see that? So I just did 1 plus c e to the t times itself. So FOIL, so 1 times 1. My outer and inner are the same thing, so I have 2 of them. My last is c squared e to the 2t. All right, the bottom is just 1 minus 2c e to the t plus c squared e to the 2t. I'm subtracting out 1, so I want to get common denominators. So this is my denominator. I'm going to have the denominator over itself. You guys look like you're freaking out, but this is just algebra.
So is it going to be 4c e to the t over all that crap on the bottom?
So you go whatever that.
Why 4? What'd you say?
But then you minus the negative 2 and then it becomes 4, right?
Okay, so yeah, are you talking about you're distributing?
The negative.
Yeah, so you get 1, you have minus 1, so it goes away. You have 2c e to the t plus another 1, and then the other ones cancel. So see how the 1 and the minus 1 are going to cancel. C squared, negative c squared, all that's going to cancel. So you do get 4 of them. So I have 1/2 of 4c e to the t all over that bottom. And that bottom was just 1 minus c e to the t squared, right? Let's write it that way. Do you see where we're going? So 4 and 2 reduced down, you just get 2. Do you see how that's the same thing? So equals y prime. So you're done.
Where did the
Algebra, yay.
I like algebra.
Where did the second what? This? It was 1. So if you're subtracting out 1, I just got common denominator, so it was this denominator over itself. Okay, so it says, unfortunately, explicit formulas for the solutions to differential equations, guys, are not always simple to find. So it's not really easy to find that this was, that this was a solution. So the y equals all of that was a solution to this differential equation. But you can actually learn a lot from the graph. So we're going to learn how to graph differential equations. So these are called slope fields or direction fields. So whenever you guys see slope fields or direction fields on your AP test, this is what we're talking about. Sketch a direction field to find the solution y prime equals x plus y and y of 0 equals 1. All right, so I know that y prime is equal to my x value plus my y value. So I'm talking about at each individual point. So see where -2, 0 is? It's right here. Oh, or that's 2, 0. -2, 0 is right there. I'll draw it in blue. So we need to figure out what the slope is at that point. So the slope is just your x value plus your y value. That was what that said. So what's the slope going to be? -2, right? So at that point, right here, we're going to have a -2 slope. So think about what a -2 slope would look like. You go up 2, left 1. So just do a little tiny hash mark. So it's like going up in that direction to this point right here. Do you see where my pen's pointing? See how it works?
Yeah.
So just at that particular point, that's what the slope is. All right, now I have negative 1, 0. So negative 1, 0 is here. Its slope would be negative 1. Add the two together because it was x plus y. So now it's a little less steep. So it looks like that. Okay, you're going to fill in this whole table. So you're going to do this for every single point. So 0, 0 is going to be 0. 1 and 0 makes 1. 2 and 0 is 2. Just keep adding.
This problem,
Do you think it's easy? So,
you add the numbers, and I like that part.
yeah.
That's a point right there.
You could at least get that. All right, so let's sketch in all these different things. So at 0, 0, so at this origin, I'm going to have a slope of 0. So a slope of 0 looks like that.
They're all zeros.
At 1, 0, I'm going to have 1. At 2, 0, I have 2, so go a little bit steeper. Always think about what corner point you're going to. Like if I actually drew on the slope, I'd go up to right 1, so I'm trying to go to that corner point. So it's just straight line. All right, then I have negative 2, 1, so go to negative 2, positive 1. That's negative 1. Negative 1, 1 is 0. And can you kind of see that all of the ones that are going to be opposite, like if I have negative 2, 2, that's going to be 0. So when you see patterns, draw them in. Like all the ones that are going to be opposite, so 1, negative 1 would have that. So see how you're going to slope a 0 all the way down there. Okay, if I have 0, 1, it's going to be 1. 1, 1 gives me 2. Oh, I drew that in the wrong place. 0, 1 is 1. 1, 1 is 2, so a little steeper. 2, 1 gives me 3, so that's real steep.
Oh, steep.
Negative 2, negative 1 gives me negative 3. So real steep there. Negative 1 gives me negative 2. 0, negative 1 gives me negative 1. So I can tell all these ones are negative 1 too. Can you see? So draw those in. Definitely see patterns. All right, 1, negative 1, have we done that one? 1, negative 1 is 0, and then 2, negative 1 gives me 1. Okay, so you have this kind of like, looks like a little magnetic field. Have you guys seen the little magnetic fields before drawn in? Shows you the different, no, you haven't. Okay, never mind. All right, so you can tell like kind of the paths that you're going along. So if I know that y of 0 equals 1, that means at 0, I should have a y value of 1. So that's going to be a point on my graph. Okay. So I definitely have to hit that point. That's telling me like an initial value. So I'm going to hit that point. It looks like it's going to come down and then go along that line maybe. So that way the slope's always going to be along there. See if you took particular points, the slope follows that. So see how it works?
No. Why did we choose that? Why not a different line?
Because that was our starting point. We wanted to start at the point 0, 1. So 0, 1. So that's going to be where we start our
That's
drawing.
the closest line we could find.
And then I'm guessing that these are getting steeper, right? So see, it's going to go along there as well. What happens is you have a lot of curves that follow. It's talking about that family of functions again. So you have all these curves. And then there's something going along here too. I don't know how that one goes. But this is the one you want. This is your particular solution. So it's kind of like that last one we just did where it talks about a family of functions. So we're going to have lots of different curves depending on what C is. But the one that we want depends on our initial value. We've now shown the path that it takes. We go along those. So let's see. So at this particular point here, you see the slope is like that. This one, the slope's that. This one, the slope's like that. See how it's following that?
Oh, yeah.
This one, it goes up. So it's following